and then we'll kind of familiarize ourselves with PLC, and that way what is what on the screen. I actually got to see it in work, and then we'll go through the auto function, and we'll show you all how that works. But let's start with flow direction. So let's go out to the EU tank, and we'll check all the outside equipment out first.
Outside big scope, so I'm just going to give you the lay of the land here. We can go over and look at that in more detail after he's done. But you've got two influent pipes coming into that lift station from the production facility, an 18-inch and a 14-inch. There's basket strainers on there to catch any large solids, caps, gloves, anything like that. Those need to be pulled out occasionally and cleaned. You can open the hatch and see how full they are and pull those out. There are two pumps over there. They're a duty standby configuration. So one pump is designed for full flow at full build out, designed for about 350,000 gallons per day with one pump. So if one of those pumps goes down, that's fine. You get a backup. Fully redundant system over there. Those pumps pump through a valve vault where there are check valves and isolation valves. The lines combine together, and that pump flow comes underground over to the equalization tank. And where this man lift is right now, that is your influent pipe for all your influent wastewaters coming in. Like I said, we'll go touch on that lift station more detail later. I just wanted to give you kind of the full lay of the land from the beginning, and I'll let Ryan water and stuff.
Okay, so this is our equalization tank. The purpose of the tank is to have the volume of water that we're going to be able to balance the pH of, and we've got a volume there to keep our DAF from kicking on and kicking off every time you get a flux in water. So that's basically the purpose of our EQ here. These are our air jet pumps, so that just keeps the EQ stirred up. We don't have any stratification. We keep that water moving in there, and that's also going to help with the balancing of the pH.
You said pumps, is there more than one?
Yeah, there's another one on the other side. So this one's B, the other one's A, or 1 and 2.
One goes down, are we okay? We'll try to get it fixed as soon as possible.
Yeah, I mean, you're still going to see some turbulence in there from just one, but preferable whenever you get some height on that tank, we need both of them running. We've got it set up now to where once you drop below a certain point, one's going to shut off just automatically, and you're only going to run one anyway. But then once you go back over that height, then we're going to have both of them kick back.
Is this airline doing some kind of Ventura thing too?
It is. That's exactly what it is. Yep.
Yeah, so that is a Venturi. So you've got suction coming into the bottom, discharge out. That's sucking air down and through, and that's why it's called an air jet, right? So it's mixing the air. You'll also notice that the discharge on that is angled slightly. So they're angled in the same direction. So when you're up there looking in, you will see a slight swirl to that tank. That's how it's supposed to be. One of the benefits of the air jet mixing system is, in addition to the mixing energy you get from just the force of the water going in there, you also have those bubbles. So you're getting some vertical mixing as well. And so it's also giving a little bit of pre-treatment, adding a little bit of air in there, just
That's what I'm saying.
keep it from going septic.
Kind of turn things aerobic.
Yeah, it does. So it is designed to keep it from going septic. So when you're in there, that's one thing to look at. That's how you can tell if these air jets are working well. You can look in there, you can see that swirl, and you also should see a nice pattern of bubbles coming up to the top. It should be pretty well aerated.
That's basically it on EQ. Of course, we have our influent lines to the DAF coming off the EQ. We're coming off the bottom. And we can step back inside if you guys are ready to do that. I just wanted to show you the research bumps here. And
Wait, and remind us again, this is our intake to our EQ. We've got a top and a bottom fill. Is the top really just an overflow? What's
so you've got an overflow on the other side.
okay?
You're filling at the top.
Okay, filling at the
Yeah.
top, but it looks like we have a port on the bottom fill.
I'd say that's a drain.
Okay,
Yeah.
got it.
Let's go around and
We could block that off and drain here if needed. Okay.
you can drain, or if there's additional equipment later in the future, you can close that, open that, and just gives you some flexibility there. I'd like to walk around the other tank, just take a look at the other air jet, and then we'll take a look at the suction pipe too. So looking at this side, you can see we've got the second air jet mixer, same configuration as the other side. The larger 12-inch diameter pipe coming out right there is an overflow. So that's what we call a passive overflow. If for some reason things go down, the tank gets overfilled, the tank will automatically overflow and it'll discharge raw wastewater out to the city. We've got our monitoring, district monitoring label right here. We'll come back out, we'll open that up. Take a look at that. There's there. And where we kind of measure our effluent flow rate. Looking at this side of the tank, in the background, in the shade, that larger pipe, that is the suction pipe going into the two pumps that transfer over to the gap. You can see that that's got a knife gate valve on it to close it and need to isolate for some reason. The other two lines that we have coming here, the lower one is the suction line for the pH recirculation loop. So that lower line goes into the pH adjustment skid pump. That goes through the pH adjustment skid. Ryan will touch on that back inside. And the upper line is the discharge of that pH recirculation loop. All that loop does, it's just constantly recirculating at a constant rate. And inside, it's measuring the pH and adjusting as needed up or down to maintain the pH to the point.
You think that an operator needs to climb that tank every day to look in there and make sure we got a good swirl? And
Nope,
Okay.
I don't think so.
as long as pumps sound good and healthy.
As long as the pumps sound good and healthy, I would say maybe once a week, climb up there, take a look, see if you're accumulating solids or foam on the
Yep.
top. Just take a look at it and just do a gut check if your level instruments in there are measuring. It's not something touched on, but there is a high level float in
Yep.
here, as well as a level sensor that goes back to the HMI, so you can see the live level.
Is the level sensor ultrasonic or pressure?
Got a pressure sensor in the bottom.
Awesome.
And that should
Good to hear.
that will have a flange on this tank. I don't know. I think it's right around the other side.
It's on the other side of
So there's a I think a 2-inch nozzle over there that has that pressure tank.
Okay, and it's got a nice valve shut off. You pull it out, inspect it, clean it, replace it, put it back in
Yeah.
without draining the tank.
We'll go take a look at it.
Okay.
Awesome.
We've got our outfall here. I assume that you guys are going to grade this out nice. Is there any talk? I mean, it sounds like this is where we're going to put our composite sampler.
Sampler's going to go inside.
Okay.
It'll be inside, so you don't have to weatherize it and have it in a little doghouse. It's going to be pulling right off the DAF effluent.
Okay, that sounds good. Okay, good. Okay. But this is, you've got your partial flumen here.
right there. So
Okay. And so you've got some electronics coming off of it for it's sonic, I assume, running back into control in here. Okay. That will need to be inspected, probably once a week at least.
Yeah.
Okay.
We'll come out and get that opened up, and I'll explain the discharge routing too before we get forward right there. Okay, yeah, let's do it now while we're good.
Remember, there's no poop in this stuff. Okay.
Tiny little partial flow.
yeah, they're not really flowing at all. Well, anything, not just residual. But there's your sensor there. Oh. You got your gauge on the side. They're flowing heavy. It went mid, almost pretty much all the way up.
All the way up?
They're flowing real heavy.
Well, the plant hasn't even started yet, so this is
They started flushing.
I get that, but still.
Yeah, I believe that was rated for 900,000 gallons per day, which was beyond our full build out of 750.
Okay.
I don't know what the flow rate was.
Well, we're gonna find out when it's bubbling out of this thing.
So, it never reached.
I'm just being an ass.
So the overflow ties in with a Y just behind us. From there, coming here, from this flume, it goes out this direction, and then you can see the straight line right there. I've uncovered the next manhole structure. that structure there is a diversion structure. So this facility right now is discharging off to the left to go out to Burley's municipal plant. In the future, there's, in theory, there will be another sewer main that the city builds off on the right side through here, through that sewer easement. That manhole has a stub that goes out about 10 feet for that future connection. There are valves there, so that in the future, this facility will have the ability to discharge either to the left, to the municipal facility, or to the right and tie into the industrial.
Are the valves inside the manhole?
They're outside.
Okay, can they access from the top with the key?
Yep, they're back. They're about to be right.
Got it.
I wasn't living here. I can check.
Okay, on that note, where's my sanitary sewer enter the city?
That I don't know, but that comes all the way from the plant, I believe.
Yeah.
We'd have to take a look at the larger plant drawing, but I believe it comes out of the north side of
It
it.
never interacts here at all.
Nope, there's no sanitary sewer in here, so this is only processed wastewater. The process and sanitary systems are completely separate. They do this wastewater, once it enters the municipal collection system, does combine with sanitary sewer downstream, but from that point backwards is all processed wastewater.
So why I want to hit on that so well is when I ask one of these maintenance guys to go change a pump, they won't quit that day. So
Yeah,
they'll be like, oh, it's just processed water.
yeah, this is not the poop water. There shouldn't be any turds floating down or anything like that. It should just be nice, sweet milk water.
Sweet milk water. It'll be sweet. Okay, sounds good, guys. What's next?
Go back inside.
Third pump, this thing is going to be running 24/7, and we've got a flow switch on here to make sure that we're actually seeing flow. The reason we do this is because these chemicals are getting injected into the discharge of this pump. We don't want no flow to be happening with our main pump and to fill this whole thing with chemicals. So we want to see a flow signal to be able to turn these on automatically. So if no flow signal, these dosing pumps are not going to come on in the auto function. Now you can manually turn them on, right? But just watch out for, filling this thing up with this pump. pH probe is right here. If you need to change it, what we would do is we would open this, close these valves, drain the remaining water, and then unthread this pH probe. Got a quick connect, quick and easy. Put it right back in. Open everything back up, and then get it to that 20 psi.
That's our target, 20 psi.
20 psi.
And those one sheet operational things that you sent me today, list all that, 20 psi.
Yep.
Okay.
It's going to list a bunch of things I'll forget today. So
Understood. Thank you. It's perfect.
here's the controller for the pH probe. We've got temperature and pH on this. So our pH right now is at a 9.8. So if we were in the auto function right now, one of these chemical pumps would be running to try to get that pH back down. And that's in our auto function. We'll go through that whenever we look at HMI.
What's our set point?
So right now I've got you at 7.5. You're gonna at 8 you're gonna run to get down to 7.5, and at 6 you're gonna run to get back up to 6.5. So we want to keep it between a 6 and an 8. The DAF sees the best performance whenever you're between a 6 and an 8. Takes down on the chemical usage, and it just helps substantially. That's pretty much it right here on the pH tree. Make sure valves are open, and in the auto function, it's going to take care of itself. One thing I will say about this is if you do have pre-screening that's letting a lot of things by, what you're going to see is a buildup on your pH probe. This pH probe is going to hang at a certain pH. It's not actually going to be reading the pH of the water. So, that's one thing to be aware of. But we've seen it in the past where this pH probe, it gets all the way down to about right here. But this top neck of this T will fill up with the fines, and then your pH probe just stays hung at a certain pH, whether that's the pH in the tank or not. So if you do see that that's a problem, if you see that a run timer has alarmed you on one of these pumps, because if they run for a certain amount of time, that's an alarm for us. You're going to get it on the screen. It's going to say run timer, on caustic or acid. It's probably because this pH probe is fouled in some way, whether it be large particles, busted the probe, screwed the probe up, or whatever the case may be. So,
My experience is you always plan to change drugs.
yeah, one thing that we've done in the past is, recommend a basket strainer in here somewhere to keep that fine stuff from getting here. But we've also put a Y strainer below this flow meter, because this is the flow meter for this controller here. We put a Y strainer here to where if that Y strainer gets clogged up with all the stuff that would go to the probe, the flow goes out and you don't just sit there and run chemicals, if that makes sense.
Okay?
So if you see that's an issue, and I can send you a picture of that installation it comes from, but
Yeah, if you would send that over to me, it might be something we request, sooner than later.
so we would just move the flow meter up, put the Y strainer down here.
Okay? Then you clean the wire stream and set it on the cobalt.
Yep. And instead of Fallon probes, they tend to break as they get up again. That's pretty much it right here on the pH tree, other than, we're pulling out the bottom of the tank, putting it back into the top of the tank. So we'll come back to chemicals in just a minute. We'll go now to the transfer pumps. So these are the pumps that feed the DAF. You're only going to be running one at a time, so it's not lead lag, it's going to be A/B select. Right now, we're on one. See, I've got the disconnect on. We're not actually moving any water through here. But down the line, we've got our flow meter, and this is the engagement for our auto function for everything past these pumps. So our DAF is going to turn on whenever it sees flow. Chemicals that we're putting into the DAF, the polymer and coagulant, are going to come on in their auto function and dose accordingly. And, the DAG pump, the rake that gets the sludge off the top, the cones that pulls the sludge off the bottom, all that stuff is going to be in auto, and it's going to come on when we see flow to the flow meter. Because, we don't want stuff running without flow. Now, you can manually turn the things on, but
Right. You mentioned the AB pump, okay, but they're not redundant unless you come manually switch them. Is that what you told me?
yeah, or you can do it we can turn the disconnects on, you can do it on the screen. Yeah, maybe.
So if one of these goes down, will we alarm for somewhere? If one of these goes down, say,
Yes.
hey, the DAF is not working?
Yeah, your flow rate's going to quit,
Yeah,
right? And then everything past that point is going to shut off.
yeah. Then it'll throw alarm?
Yep.
Yeah, thank you.
So once we get to the DAF, we go through our flock tubes here. Before we get to the flock tubes, this is our main control valve. So this is going to keep flow from happening. So if this thing is closed and it's not an auto, even if you turn the pumps on, our auto function isn't going to come on because flow meter's not actually going to see flow. And you've got to get above like 50 gallons a minute for the auto function to actually engage. So this is how, in tandem with the pump, that knife valve is going to fluctuate and try to achieve the flow rate that we set on the PLC. Because it's going to be up to you to determine how many gallons a minute on average you think you should run this thing. Keep it running, as much as possible. Starts and stops are not good for a DAF. It's going to take this unit about 30 minutes to get back to where it was when it was running after you start it back up. So if you can minimize start and stops, it really helps your treatment. So the flock tubes are here just to get the coagulant properly mixed into the water before it hits the DAF. That way our polymer there has a better chance of grabbing the larger solids and bringing them to the top. So that's the purpose of the flock tube. So, of course, if we follow the line, we've got the influence of the DAF right there. And we've got 3 options for your polymer, and you get to pick where your treatment is best. We normally see the best treatment if we inject the polymer right here where the aerate, the DAG pump discharges to. But you may see better treatment if you put it right into the header box over there with the other 2 valves that are closed. So it's, you know, whatever you see. And unfortunately, I'm not going to be here to, whenever we do run wastewater, to kind of help out with this. But, you know, it's worth playing around with. You can really see a substantial difference by changing your injection point on your polymer.
Who will be here to help us when we're actually have loadings?
Well, I mean, we could come back out if you guys wanted us to.
Yeah, so I mean, I think today's great, kind of functional how things run, but I mean, we're not running a wastewater plant today. We probably won't be for weeks. Wastewater plants are all judged on loading removal rates. So we're going to need some help in the near future to come back and, you know, I would say a real commissioning.
Yep.
When we're actually seeing our flocculant, our polymers, our air, our DAF, everything working together to actually do their job, not just fill full water and test it full.
No,
So we would,
100% agree.
that may not have aligned with the project, you know, at the first. Maybe we all thought we were going to be running something by now. I get that. But in the, I guess the point of it is this is all superficial right now.
Yep.
Until we actually start getting loadings coming down. I know you'll be here to help us.
Yeah, so I'll be the local resource, and we'll get World Waterworks up here too if we need to help dial things in.
But yeah, once I get more people on staff, we would love to have you guys come out and spend a couple of days with actual loadings to help tune the system and do a lot of training.
Yeah, we'll absolutely do that. Just get with us. We'll put it on the schedule.
Right.
Yeah. So at this point, we've made it all the way to the entrance of the DAF. Let's, if we want to, we'll go up the steps, and I'll
So it looks like maybe the final water comes back in these tubes. How exactly does that work?
Yep, it's good. So the head pressure is going to push it through the main cell,
Yep.
and we've got lateral lines that run from those effluent tubes
Okay,
through the main cell,
okay,
and that head pressure is going to bring it up. And if you look at those tubes, those weirs,
yeah,
they're adjustable. So that's how, by flow rate, you want. So the higher your flow rate, the more water you're going to have in that DAF. So we would
Water
lower
quality.
them a little bit to get them to the right elevation.
Yep.
Lower the flow rate, we would have to lift them up to get that water to the right elevation.
gotcha.
So
Yeah, I've never seen a cylinder wear gauge before.
you've seen slide gates?
Yeah.
Yeah, slides, yeah.
Okay.
Yeah, so we're coming in on the side here, and if you look over on the right-hand side of that DAP, you're going to see a dam. You'll see where we come in, and then you'll see a plastic dam that water has to come up and over to get to the main part of the cell.
Oh, well, sorry,
But basically what that's doing is just making it to where this water in the main cell of the DAF isn't so turbulent. So we're knocking a lot of the turbulence out by putting that dam there. Water hits the dam, has to go over the dam to get to the main cell.
And my beach is down there.
I'm sorry?
Beach.
Yeah.
Okay. Okay, so it's driving, guys. So what it's doing is flocculant, polymer, all that stuff combined, pumping solids, and then air's driving. There's air entrapped in this, and it's driving it to the top there is. And then it's pushing all the solids from the top that way, and then taking clean water this way. So it's kind of like separated that way.
Yeah, and that's the next stop is the DAG pump, the dissolved air generator. So if you guys are good up here, we'll go back down to the DAG. So this is our DAG pump here. DAG, DAG stands for dissolved air generator. Basically what we're doing is we're pouring out of that main cell of the DAF, pulling water out, taking it through this air whip pump, the DAG pump, injecting air, and then taking it back through this pipe to have that mix of dissolved air and water shot back into the influence stream. And what we're doing there is we're getting the mixing energy that we need for that polymer to actually, get around and grab onto the solid. That's going to allow your solids that are lighter to float to the top and get raked off. You guys saw the rakes while you were up there. And all that will be pushed over to your scum beach, as you call it, and then pumped to your sludge tank. So that's what she does here. The set points are over here, and if you guys want to come around here,
Those are my air set points.
yeah. So that's the set points for discharge pressure, PSI for your gauge, your regulator, and then you've got
I love how you got the set points right here.
yeah, yes,
That's
sir.
awesome.
And then you've got your CFH there too.
Okay.
And this is going to be engaged in the auto function by that flow meter, like everything else. So one thing I'll say on this DAF is the way we have this set up is make sure there's water in the DAF before you put this in auto, or else we're just going to run dry. We don't have anything that's going to say, hey, we have water, this can turn on. It's just going to say we have flow, this is going to turn on. We may not have enough water in there yet, after you've cleaned or something like that.
Okay.
Yeah. And then just while we're here, that's your AOD pump. So that pump is going to be pulling the sludge out of that sludge hopper and taking it to your sludge tank. And we try to use those because, they seem to work well, and they'll push toenails. So and then you guys saw the effluent chambers, and we can talk more about the weirs if you want and how to dry your sludge. If you're seeing that you have good water and your sludge is a little wetter than you want, we may lower the weirs to where we're just taking drier solids off the top, or, it's manipulate. You can manipulate it to get the product that you want.
Okay.
Okay.
Like how you guys have put, the torque specs right on those, it's pretty handy.
Yeah.
What are those access panels for?
So that's the lateral line that run through the DAF. And it's, if they get real bad gummed up or you need to access them for any reason, you've got a point there. But we've also got a way to clean them, which we'll do, we suggest doing twice a day.
Well, yeah,
on
that's
the
what
other
I'm
side.
thinking. How do we blow down the bottom of the thing?
So we'll go over to this other side. So these are your lateral lines, just like we saw on the other side. They run through the DAF and they connect to those weir pipes that are coming up on the other side, or on the discharge side of the DAF, effluent side. We just hit them with a little bit of air twice a day just to clean the crap out of them. I think we've got 8 PSI on the regulator there. Don't go much higher. You'll shoot water up to the ceiling through those effluents. But that's how we kind of purge a little bit of the debris out of those lateral lines. Now, we're done with that. We'll go to the bottom solids. If you guys look on the bottom, you'll see that there's some automated valves there. You've got manuals too for isolation. But automated valves, there's 4 of them. Yeah.
Yep.
So everything heavy is going to, and we call those the cone. So you can kind of see how the DAF goes down into a cone at the bottom. Everything heavy is going to settle there. And that's another thing that you get to manipulate is the timers on how often you want those to purge. We don't want it to run for more than I'd say 5 seconds at the max, because you go any further than that and you just channel and you don't actually get the solids out. So I would say leave the open time to 5 or below. Just increase the amount of times that you do it, and that's all adjustable on the PLC, and we'll go through that here in a minute. But that's basically it right here on the DAF. And I mean, once we'll go through the screens, and then we'll start everything up because we have some water in the EQ, and we can watch this thing work.
I assume that torque value is very important, not just because of the sill, but it looks like what this is made of, you don't want to over torque.
Yeah, plastic. Yeah, we don't want to over torque that and strip those threads.
Maintenance guys will make note of that.
Oh, let me go back to the DAG here real quick while we're here. So the discharge of the DAG comes through this stainless pipe here. And we've got our pressure sensor for the DAG right here off of this gauge.
Okay.
So that's reading on the HMI, and we also have shutoffs for that. So low pressure for too long is going to shut that off. High pressure for too long is going to shut that off as well. So the DAG will just kick off. I've got it set up now to where it just comes on and runs. We're achieving the right pressure. Once you get wastewater in here, it may change. Yeah. So we achieve that back pressure with these valves here. So we choke these down to get that pressure in this line.
Right.
And then that turbulence is of course mixing with the polymer. So let's say we turn the DAG pump on, things are running in the auto function, the DAG pump comes on, and it shuts itself back off. You know, it may say low pressure on the alarm or high pressure on the alarm. I would tell you guys the first thing to do is come over here to this bleeder and bleed the air right here. Bleed the air out of this thing, because that we are forcing air into that DAG pump. So if we force nothing but air into this pipe here, it's just going to stay that way. So this is a bleeder to get the air out, to get it full of water. And then we also have one over here at the DAG pump itself. So we'll bleed the air out of that point. We'll bleed the air out of this point. The discharge of that DAG pump. That way we know the suction's full of water. And then we'll try it again. This valve here, connected to our header box, this one stays wide open all the time. This is to get the coarse air, the big air bubbles, out of the water. This one is attached to the pressurized line that we want that 90 psi, so we just want it cracked. And whenever we get to running, I'll show you more about this, but you're going to see some flow coming into the effluent chamber. It's going to look like a lot of flow, like why the hell is that running? That's what we want. We want as much of that big air out of there, so we don't, fill this full of air. We'll go through all that again whenever we're running, but this is our polymer skid. So I don't know if you guys are very familiar with polymer, but if you are, you know that polymer and water is a nightmare. It's going to gum up, it's just a mess. So what we've done is we've made it to where if you don't have the right water pressure on this skid here, it's not going to come on. So if I had this in auto and we were running water and this thing didn't see at least 30 psi, it's going to just shut off. Nothing's going to work, right? And if we look down here at the bottom, this is that pressure switch. So if we're in auto, everything's on the way it should be on, and you guys come over here and you're like, why the hell isn't this thing running? Check out your pressure. We've got to have that pressure. And whenever I come back, or whoever comes back for the actual commissioning of all this stuff, whenever you're actually treating wastewater, we'll set this skid up to the right ppm and the right water dosage. The more polymer we put in here, the more polymer we start injecting, the more water we're going to have to use to carry it. If we start throwing more polymer and don't adjust our water, then we're liable to gum this thing up. So this little AOD pump here is just recirculating polymer. It keeps you from having to put a mixer on your polymer tank, on the top of your polymer. So we're just taking it out, putting it right back in, filling up this gauge, with the polymer. Then from there, we used our dosing pump to pull out of here and to put it up here into the mixing team. So we want more water flowing past, flows this direction. We want more water on this side normally than we do on this side, just so we don't get gummed up right here in the port. But if you do get gummed up, it's not the end of the world, of course. We just pop these unions loose, make sure everything's off. Pop these unions loose, and there's a little bitty port in this T. And you just take something, push a little bit of polymer through there, and you're back in business. But it's really crucial that we have our 30 psi at the flow rate that we're wanting here. So 30 psi at operating, while we're running, to be able to get this thing to turn on. It's not going to turn on unless you have it. So this is our coag, and we've got water running, carrier water running to it as well. But if you do see that your pressure is not that great, if you do see that the pressure is not that great here, my suggestion is just taking the water off here, killing a little bit of this flow. Coag doesn't necessarily have to have it to get there. It's not going to gum. The coag's not going to gum up like the polymer will. So I would say sacrifice the carrier water there to get the pressure and volume you need to. So our coag is being injected pre-transfer pump. We're going into the suction of the transfer pump. You can kind of see the injection quill there. Getting mixed up in the pump and then getting discharged over, going through the flock tubes and into the DAP. Our polymer is being injected at that small header over there at the inlet of the DAP. And that's the two DAF chemicals. And of course we know that the caustic and acid is how we're going to adjust the pH on the EQ tank over there. And we'll come back and touch on all this stuff, briefly. I just, mainly in the beginning, I want you guys to see what it is before we get in there on the screen. And, you can kind of say, oh, okay, well, I know where that's at. I know what it looks like. Whenever we are running polymer through here, one thing to note is what you want to see in this little static mixer here is just a burst of cloudiness. So you want to see clear water and then a burst of white. And then clear water, burst of white. Clear water, burst of white. If you see all white, we don't have enough water flow running through here. So we need to up that a little bit. That's just going to keep you from gumming things up down the line and make your life a lot easier. So, the visual is, do I see the burst? Do I see clear water, then a burst? Clear water, then a burst. But that's, in a nutshell, that's it out here. Once we get running, things are, we'll talk about a few more things, but here with the front page, we've got the overview, and our overview will take you to the EQ. You can see that the things that have to do with the EQ are on this page. So the air jets that we looked at outside, they're both right here. Oh. They're both right here. And then the pH research pump, the pH tree over there in the corner, that's right here as well. You see we have two signals here. We have a run and a flow. The flow is that flow meter is seeing flow, and the run is we've just got it on, right? So any of these pages, by the way, guys, if you want to get to a more detailed page of any of these pieces of equipment, we can just hit it, right? So if I hit the acid, it takes me to the research, acid, and caustic right there on that page. You don't have to try to find a new page. You can just punch it. If I want to get to the air jets, I can just punch the air jets right there. We're in auto, running. So we'll just start here. Anything in a white box is adjustable by you. You get to change that. So we've got right now our start level for airjet A is 5.5 feet. So once you get to 5.5 feet, it's going to turn on in the auto function, which you see it's in the auto function and we're running. Once you get to 5 or below, it's going to shut it off. We've got the other one at 6 and 5.5. So these are your auto function parameters right there. That's going to turn the pump on and off. So right now our EQ level is 10 something. So I'm going to put stop level at 12 feet. And if everything's right, we should see that turn on. So you see how airjet A is in wait now. So we just turned that pump off just by changing the set points right there. Yeah, definitely. So yeah, anything you see in a white box, you guys get to manipulate. Back to the viewer. Also on this page, we're not really controlling any of those lift station pumps, but we do have some signals that are coming here. So we've got a high level, so that's a float that's going to be in that lift station. We've got a low level float, and then we've got a run signal, overload, and oil right there. So, you know, that if you see that any of these are red, whenever we're finally up and going, if you see that any of these are red, you're going to get an alarm for that on the screen. So we'll go to the pH recirc now. So notice whenever I went to the pH recirc pump, it brought me the recirc pump, the acid pump, and the caustic pump. We try to keep things that are, you know, have to do with each other on the same page, so you ain't got to go 3 different places to do one thing. So if I was to put this thing in auto and we were to see flow on that flow meter, these pumps are going to automatically start adjusting that EQ tank. Because right now we're at like 9.8 and our target is around a 7, right? So we would see the pump kick on to try to drop that pH in the auto function. And we'll do that here in just a minute. We'll go back through this stuff real quick here in a minute. Now I'm going to the DAF overview page. We've got the positioning valve, which is our main control valve that we saw right there at the flock tubes. We've got our flow rate here. Notice we say no flow. So that means anything in auto is in wait at this point. We've got our rake. We've got a rake that gets the top solids off, right? We've got the coag and polymer because those are the 2 chemicals that are going to be dosed at the DAF or have to do with the DAF. And then we have our transfer pump 1, transfer pump 2, the hopper control valve. If you guys look out the door there, you'll see that valve that's on that line, that PVC line running down there. We've got our sludge pump. That's that blue AOD pump. Let's ignore this for now because this is your sludge tank. And then we've got our cones. If they were in auto, of course, they would be in wait until their timer turned on. We've got a main air signal here as well. So if you see that this main air is low, it'll be red and say low. It's not going to turn anything off. It's just for you to know, hey, something's wrong with your air. We need to get this rolling, you know, figure out what the problem is. And then we've got the DAG pump. And you notice we're displaying that pressure right there at the DAG pump. So I'll go back to the main page. So that was the overview. And we're going to go back through the overview in a minute. But now I'm going to go to alarm history. So these are a lot of startup alarms that we've had just by getting everything going. We can clear that if we want to, but you know, it doesn't really have to be. I would say that once you guys get rolling, don't clear the history. It just makes it so much easier to diagnose a problem if you don't clear the history. So, keep that all on there. We've got a clear history button on there, but if, for you and the next guy down the line, having these alarms show up on this page is pretty crucial. Oh, sorry, while I'm there. So you've got 3 VFDs on this project. We've got the 2 transfer pumps, VFD variable frequency drive. We've got the 2 transfer pumps and then our rake. Those are the 3 VFDs we have here. So what we've given you is in the alarms page, we've given you a VFD status page. So if we go to alarm history, the VFD status, you can see that those 3 VFDs are good. If you have a power outage, they're going to fault. You're going to have to reset them right here. So what we do is we go transfer pump, rake gear. If the transfer pump is faulted, we would go to the transfer pump, whichever one it may be. I would turn it off, and I would go back to the VFD status page, reset, go back to the transfer pump, and then put it back in auto, and you should be good to go at that point. Just keeps you from having to get in the control panel and resetting it right there at the VFD. The next page here is our trends. So we've got it for right now, we're in flow. So we've got your DAF feed flow and your effluent, which is that pit outside that we were touching on earlier today, or earlier during this. And at the DAF feed, we've got gallons per minute. We've got gallons per minute on the effluent. You're going to see those lines on here, right on the trending page. So that's another way of diagnosing a problem is you can come back in and say, well, what were we actually flowing 4 days ago? The city hits you with something, you may be able to come in here and fact check whatever information they have. Let's see. So this is the trending page for your sludge tank. It's just going to tell you what you've had in the tank, of course. You can kind of see the blue lettering there, and that's our blue line. Okay, so if we hit that EQ right there, right? It's going to take you to the trends that come off of the EQ tank. So you're going to see level, you're going to see pH, and you're going to see temperature, and all those are going to trend on the same screen here. So we're seeing EQ, we're seeing flow. See what that is. And then sludge tank level, you've got those. And yep. So you got 3 pages there that you can get some pretty good information off of. If you want to look into the past, you hit this 1,000,000 times and go back 1,000,000 days or whatever. Then we'll get back to current. You just hit home. What? Oh yeah,
Tyler?
So let's get to set points here, and this is a pretty crucial page. DAF and auto. So this, like I said before, if it's in a white box, you can adjust it. So DAF and auto, this means what gallons per minute does that flow meter need to see to engage the auto function? So if you say, 50 is too low, I don't want shit to come on, I don't want stuff to come on at 50 gallons a minute, we just hit it, change it to whatever you want, 150 or whatever. I'm going to put it back to 50. EQ tank high level. So this means that whatever you input in here, as far as feet, whenever it reaches that, that's when your alarm's going to come up. So you get an alarm on the screen once the EQ gets to 25 feet, or whatever you set it at. This is adjustable by you. EQ tank high level reset. That's just saying what what height do I want that alarm to reset? You know, what height do I want that alarm to go away because we're good now? So that's adjustable by ear as well. Same thing with the sludge tank, high level alarm, and then the high level reset. EQ tank, high pH. So I've got this one on a 12 right now just because I didn't want to run any chemicals without anybody near, and I didn't want to have a constant alarm. So I'll change that whenever we start everything up. But that's just, you know, an alarm. So once it gets to 12, it's going to alarm you. Once it gets to 6, it's going to alarm you. EQ tank high temp, same thing. EQ tank low temp, same thing. And these are our run timers. So these are the excessive run timer alarms that we have. Still, you know, like I said, adjustable by you guys. So if that acid pump runs for 120 minutes, we're going to get an alarm. We're going to shut it off and say, hey, this thing's hung up. Something's wrong, you know. And then we've got 60 minutes on the caustic. And it's adjustable by you guys, of course. So this is just a reset for your totalizer. You know, 23 hours, 59 minutes. That means every day you're going to reset that totalizer that comes up at the bottom of the page. And this is some other stuff that's got to do with the devices that will get configured whenever they get the devices in and get them all going. So let's say the flow meter goes out and you've got to replace it, but you can't stop the process. You still got water coming from the plant. It's going to happen eventually, probably, maybe, I don't know. But in case it does, we give you a flow bypass option. So basically what we're doing is we're saying you get to input what you want the flow meter to see. You're going to have to make your best judgment about what the actual flow rate is because we dose our chemicals for the DAF off the flow rate. So you're basically at this point being the flow meter. You're saying, okay, I think that's 300 gallons a minute. You're going to input 300 gallons a minute for the bypass flow rate, turn the flow bypass on, and it's going to act like that flow meter is seeing flow. You know, only use it whenever your flow meter's out and you've got to swap it or wherever it is, and you need to keep going. So that's the set points page. This is an important page for you guys, you know, to really dial things in around here. Okay, if we go to the EQ airjet page, takes you to the 2 air jets out there. Go to EQ pH controls. We've been on this page before, right? You got the recirc pump and the 2 dosing pumps, pH dosing pumps. DAF feed is going to take you to the transfer pumps. And I said a while ago that it's an AB select. So if you want pump 2 to run, see where it says pump 1 here? We just hit that button. Now we're on pump 2. Go back to pump 1. Your control valve and your flow set point. So these 2 things work in tandem. The feed pump works in tandem with the control valve to find the flow rate that you put right here. That doesn't mean you can't manually run them. You know, if I wanted to open the control valve right now, all I got to do is say I want 50% open. I just hit manual, you heard it open, right? So now it's at 50%. Put that back in auto. Now we're in auto. It shouldn't be. We're seeing flow somehow. Oh yeah, head pressure, sorry. So I'm just going to turn that off. DAF controls, DAF chemicals. And then we get to the coag and the polymer. So this is where you get to adjust things if you say you want to go with a bigger polymer dosing pump, say you want to go with a bigger coagulant dosing pump. What you're going to have to do is find out how many gallons per day that pump will do and come in here and input it into these white boxes and your parts per million. So we take all this information along with the flow rate that you're actually putting through the flow meter to figure out how quickly that pump needs to run. So we just do it off a ppm basis. I know a lot of people do it off of milligrams per liter. This is what we're familiar with. This is what people seem to get familiar with more quickly. You know, it just makes things easy. So say you get a bigger pump, you're going to have to figure out how many gallons per day that pump will do. You'll come over here, input it into that box. Say it's 650. Add 412 in there. Don't let me forget that. Okay, that ain't going to work. I'll go down. And that's going to dose accordingly. What I have in there? 412. Yep. Same thing with the polymer. You know, and these two are the two that's important because we're dosing based on the flow rate. So the other two, you know, it's whatever, but these have to be set up accordingly to get the proper dosing for the flow rate. So we put all this in, you go from, you know, we're putting through the flow meter 300 gallons per minute, and we're running at, you know, 10%. And then we go up to 500 gallons a minute. That pump's automatically going to ramp itself up to be able to do a dose of morphine. And that's it here on the screen. So what we're going to do now is we're going to put some water through the system, and you guys are going to see, you know, our auto function come on. So flow meter sees flow, we get an amber light. Our auto function is engaged. Red light, alarm, of course, go to the alarms page. Green light, and this one's probably the most important because after things have been shut off, you're going to have to come over here and push this green button to get this light to come on. The amber light won't come on if your system on light isn't on. So green button to engage everything, and then the auto function will be engaged with the amber light. So we're on, we're good there. I'm going to go to EQ, or I'm sorry, DAF. These are where the transfer pumps are. What I'm going to do now is I'm going to go through and put everything that I can in auto without the chemicals. We'll do the chemicals later, but so not the positioner because head pressure is going to push it through there. So rake needs to go in auto. DAG needs to go in auto. Sludge, that's not hooked up, so we're going to leave it off, but it would go in auto. Cones, auto. Oh, yeah, let's get to the cones here. Notice we've got open in seconds, closed in minutes. We've got the same thing in the rake for the rake. Open or on is in seconds, off is in minutes. And you know, that's manipulated by you guys. But right now I've got every hour and a half, each one of those is going to open for 5 seconds. If you guys take it down for a cleaning, if you guys take it down for a cleaning and you see that there's a lot of solids in the bottom, I would say adjust this to make this close time less. So, you know, take it down to 45 minutes. Rather than making the open time longer. What happens is you push some of that sludge out of that cone, but then that water just channels and it doesn't actually get any of the bottom solids out. So this is the one you really want to adjust first, is how often you want this to happen. I'm going to put you back to 90. And this is stuff that I'm you know, guessing here because until we get water, there's really no way of knowing. So I've got the sludge off. See, rakes and weight. Hoppers open sludge. Yeah, we don't want that. Wait. Dags and weight. All right. So now I'm going to put that control valve in auto. And because our start level or our stop level is 7 feet and we have 11.5 in the tank, that control valve in auto is going to go ahead and automatically open. No, it didn't. It's in weight. Oh, I must have done that because I didn't. Okay, so now your control valve's waiting actually until I turn this pump on. So we're above this 7 feet stop level. So if I go in auto with pump 1, the pump starts to ramp up. And now that we've got everything else on in auto, once that flow meter sees flow, sees that 50 gallons a minute that it needs to see. What the hell's going on there? Hold on a minute. Give me just a second. Maybe I've got a valve closed. What we heard get loud there at 88 psi. The rake is in wait and the cones are in wait because they're on a timer. But wait means auto. You know, if you see something that says wait, that means we're in the auto function. Off is off. You know, manual is manual.
Valve's open. Are you getting flow yet?
Yeah, we're getting flow now. And as you'll see, the pump speed is ramping up to try to achieve that 300 gallons a minute that we have. Oh shoot! Set right here. So we got 11.5 feet. We can let this thing run for quite a while. It takes it a little while to finally get to where it needs to go as far as flow rate, but it'll balance. All right, so we'll do the coag now. You can just throw it in remote if you want. So notice that we're at 5.6 milliamps on this pump. I'm going to go increase the flow rate to 500. And you'll see that milliamps go up. So you know we're adjusting with flow that way. It's been taking a little while to get there, but we're at 370 now. I don't think we quite got the water pressure to do what we need to do, so I'm gonna go put it back down to 300. Because you know, the more polymer we put in, the more water we're gonna have to go through the system. Because I'm sure your plant potable water is pretty high pressure. I'm sure it will be.
All potable water? Yeah, it'll probably be about, let's do it.
All right.
Oh, no.
All right, I'm going to go put the pH balancing pump. But we have a local off and remote switch there. So I've got all the chemicals on off right now. So I'm going to go ahead and put them in auto. We'll just do the DAF chemical for now in auto. So whenever I go over there and go to remote, these things should start dosing. Yeah, polymer, low water pressure. Oh yeah. I'll go turn that valve back on. We can go do that right now. We're above 30 psi. Notice the pump is running. I gotta turn this AOV pump back on.
No, isn't that cute?
That seems to push polymer or pull polymer a whole lot better than these little bastards. They just don't want to pull any, pull it at all.
So we're getting that clear, cloudy, clear, cloudy.
Right. That's what you're looking for. As long as you see that clarity, you're okay. Since we're trying to bring the pH down, of course, this is the acid is what we're going to be using. That's why it's powered on. It might take it a few minutes, but being as that's running at 100%, it shouldn't take too long. The reason it's running at 100% is because we're over that 8.5. So once we start getting closer, it's going to slow down. That way we don't overshoot. We don't put a bunch in and then you put in some acidic water from the plant and, we've overshot our target. That way our chemicals aren't just battling each other all the time. And those relays are set up in this controller right here. With those one suites that have all that information that'll be set it up with me to it and so on. Well, and it won't take it long. You know what? We've already dropped 500. It really shouldn't take it too long. If you see that excessive run timer come up for either one of these pumps, there's a problem somewhere.